This video is going to go over the first big idea of British Columbia's Chem 12 curriculum, which states that reactants must collide to react, and the reaction rate is dependent on the surrounding conditions. So we're going to call this unit Reaction Kinetics. Some quick definitions real quick. What is the reaction rate? So the reaction rate is the speed of which a chemical reaction occurs. And that means reaction kinetics is the rate at which a reaction takes place. So moving on, how do you measure the rate? The general formula of it is the change. This is delta, the triangle is delta, and it just means change. So the change in amount of something over the change in time. And with these changes in amount in time, it would be the final minus the initial. So the formula for rate would be the final amount minus the initial amount over the final time minus the initial time. So what happens in a chemical reaction is that we have reactants turning into products. So what happens is that collisions happen between the reactant molecules that cause bond rearrangements, that's happening during this arrow, and then end up with the products. So in general, the reactant bonds are broken and the product bonds are formed. And so collision theory states that rate depends on the collisions between reactants. So it depends on the collisions between these reactants that turn them into the products. And with that, there are multiple factors that can affect the rate of collisions between reactants. The first of which is the temperature. So with an increase in temperature means an increase in the kinetic energy of the reactants, which increases the speed of the particles. And with this, you can think of a bunch of toddlers running around in a backyard. So if you have a bunch of toddlers running around, there's probably going to be some collisions happening between them. And if these toddlers speed up, then chances are there's going to be more collisions between them. So with more speed comes more collisions between the particles, therefore causing an overall increased reaction rate. The next factor that can affect the reaction rate is pressure. If we look at these two diagrams, we can see that they have the exact same amount of particles inside. It's just that there is more volume on this left side than on the right. So if we think about it, the one on the right has a lower volume, and in turn, that means a higher pressure. So, with a higher pressure comes a lower volume, which means that there is less space between the reactants, which means that there will be an increased number of collisions, therefore causing an overall increase in the reaction rate. And the important thing to note with pressure is that this is for gases only, because you can only compress gases. The next factor that can affect the reaction rate is the concentration. So again, if we take a look at these two diagrams, the one on the left has a lower concentration, whereas the one on the right has a higher concentration, so more particles. And with a higher concentration, that means that there are more particles in one space, which means that there will be more collisions between them, causing an overall increase in the reaction rate. And the thing to keep in mind with concentration is that it only affects aqueous and gas solutions. And this is because solids and liquids will have a constant concentration that cannot be changed. The next factor is surface area, and this is for solids only. So if we think about it, in the increase in surface area, that means there's more surface exposed for reactants to collide, which means there's an increased chance of collisions, which will lead to the overall increase in reaction rate. The next thing that can affect the reaction rate is the phase or the state. So it goes from aqueous solutions having the fastest reaction time, then gases or liquids, and then solids. Next we have bonds. So reactants with more bonds, it means that it takes more time to actually break these bonds, which leads to an overall decreased reaction rate. Finally, the last thing that you really need to know of what could change the reaction rate is the addition of a catalyst. So by definition, a catalyst is a substance that increases the reaction rate of a chemical reaction without itself undergoing any permanent chemical change. And just from the definition itself, we can get that the addition of a catalyst will increase the reaction rate.